And welcome everybody to the Daily Space Weather. Coming at you here from the Smash News Network, least busted name in news. Smash no nonsense is what we are all about. We've got some activity rising in the southeastern limb. Besides that, a pretty significant dip in solar activity. How low will it go? Let us know in the comments what you think. And let's take a look at some more views here, as there's plenty of stuff to cover despite diminished solar activity. So first we'll zoom out here and take a look at the filament fest that's going on. Lots of filaments, some major coronal mass ejections to cover as well. So lots to do today. Here's the northeastern limb. You can see major filamentary activity there. Lots of prominences here all around the four corners. Here's the northwest. Huge filamentary behavior going on up there as well. Part of those filaments are still suspended up there by the sun's magnetic fields as they fight against gravity. And here's a bunch of stuff going on in the southwest as well. So we've seen a significant reduction in sunspots here as forecasted yesterday, as a bunch of major groups have set and some more are setting in the north. We've got 0 sunspots in the southern hemisphere at the moment. Here's your colorized magnetogram. That's yesterday plus today from SDO browse data. And let's talk volcanoes. So we're always interested in what's erupting. And that image there, that is of Suwanose-jima. 2 days ago on the 25th. Nishinoshima. Yes, Nishinoshima. All right, so there's Nishinoshima. No indication on the flight level over that. Kadivar now on the list as it explodes northeast of New Guinea. Kadivar producing a flight level 050. It's a 5,000-foot plume of volcanic ash. Krakatau, 2,000-foot ash plume over the Sunda Strait, part of Indonesia. The daughter of Krakatau, producing a 2,000-foot volcanic ash plume. 14,000-foot ash plume over East Java, Indonesia from Semeru. Villarrica producing some ballistic jets there in that image. Popocatépetl exploding, flight level 220. It's a 22,000-foot ash plume over central Mexico. Headed down to South America, we've got Nevado del Ruiz exploding, flight level 190. That's in Colombia. Sangay, Revenador, and Cotopaxi all erupting in Ecuador in an explosive fashion. 20,000-foot ash plume over Sangay, 15,000 over Revenador, and a flight level 220 over Cotopaxi. It's a 22,000-foot ash plume. Also, Sabancaya probably erupting. We're unable to detect that down in Peru. It's probably cloudy. Also, Lascar here showing up in the list. Volcanic ash not identifiable in satellite data. And Villarrica producing Strombolian activity. And let's check earthquakes. There's the 90-day bar graph. It's been pretty seismically calm here over the past 24 hours. And let's check the list from USGS. So let's just scroll up the list here. We're gonna cite any quakes that are over a 5 magnitude, like this 5.1 out in the Aleutian Islands there in the North Pacific. There was also a 5.2 and a 5.3 at the Reykjanes Ridge. Those quakes only about 12 minutes apart. Great example of a foreshock. A 5.2 and then a 5.3 at the Reykjanes Ridge at the Mid-Atlantic Ridge in the North Atlantic. And let us know if we miss anything on the list. It's time to get back to space. Oh, we've also got a 5.0 here down by the Southern Ocean there south of Australia. That 5.0 came in at 5:29 this morning. And here is our filamentary imagery of El Sol, a.k.a. Helios, whatever you'd like to call it. Remember, folks, we don't need sunspots or solar flares to see coronal mass ejections. A prime example right now of lots of filaments in plenty of CMEs here, despite solar activity dropping. So we've also included, just for your viewing pleasure here, we've also included 211 plus 335 angstroms. Not sure if we've ever showed those wavelengths on the channel before, but we've got multiple coronal holes rotating in here from the east. You can see those dark regions there. Those are the coronal holes. And we've got a cosmic ray report coming as well. First, the radio flux, which is now all the way down to 151 solar flux units, a huge dip. And let us know in the comments where you think this will drop to. I don't think it's going to get below 130 solar flux units. Let us know in the comments what you think, though, where the next support level down will be before we see an additional increase in solar activity. Remember, folks, we are a couple of years from solar maximum. Here's the space weather enthusiast dashboard here. No space weather storms, geomagnetic unrest, etc. forecasted there by NOAA. And we're seeing about exactly what I forecasted yesterday on yesterday's space weather video in terms of solar wind, although it's a very weak coronal hole high-speed stream. Looking at global geomagnetism here, we see a KP index of 1.67, and here is Earth's magnetic moment from space for the past 4 hours. That's our geospace magnetosphere movie. Again, things pretty calm, despite a high-speed coronal hole wind stream. And we'll get to the data on that here momentarily. First, Earth's magnetic moment from the ground. That's our ground magnetic perturbations map. These will be the most likely places to see the aurorae. Also for pipeline, railway, and power line induction. Yes, weather from space. Changes to Earth's B field, geospace delta B. The units here are nanotesla, magnetic flux density, and let's look at the real-time solar wind. So just as we forecasted yesterday, we saw a tiny little uptick here in the solar wind density, and then a downtick, and then an uptick in the solar wind speed. So the solar wind speed did make it up to, well, we're near the highs here in the past 24 hours, actually. Current conditions are, well, they've recently dropped down, but they made it up to 577 kilometers per second at least. Current conditions are lower than that at about 532 kilometers per second. Solar wind density just under 12 protons per cubic centimeter. The rest of that pretty uneventful. We are also seeing a change in the magnetic field there. So pretty weak fields, pretty unremarkable last 24 hours of solar wind. Next, we see some maneuvering here from the GOES 16 and GOES 18 satellites. That's what those arc jet moments are. When they turn on their thrusters, they produce plasma, which can affect the magnetometers. Those are their readings for the past 3 days. And let's take a look at the heliospheric current sheet next. Now, I tell our viewers regularly that this data right here is great for forecasting solar activity. Now, yesterday, I stated that I thought there would be a sunspot rising soon in the southern hemisphere, and it's all got to do with the heliospheric current sheet. If you know how to read this data, perhaps because you understand physics, this right here, this portion of the North Pole current sheet popping through was the indication that I used to make that forecast. And it does indeed look like there is an active region rising in the southeast. Let's take a look at our line of sight field plot briefly. Solar B field depicted here in blue. As we watch the progression of solar cycle 25, here is our coronal hole line of sight plot. And that's some important data there, as we do see the south solar polar field finally leaving the south polar region. We've got some north pole magnetism hanging out down there. North coronal hole looks like it has left the polar region a little bit here. So there's a long way to go to get to solar max here, folks. When you're at solar max, you can expect to see zero magnetism at the poles and lots of coronal holes around the equator. At the moment, we aren't there yet. That is not solar max. So for all the channels that are telling you that it's solar max, I don't know, refer them to our channel. We cite facts. So here is the 211 angstroms wavelength for the past 24 hours. And these are all South Pole-oriented coronal holes besides this one. So interestingly enough, this one down here is actually North Pole-oriented, as you can see here on this imagery that is showing up green. So we've got a North Pole coronal hole here, a South Pole coronal hole right there, and then these are all South Pole-oriented as well. So we can expect a high-speed wind from this one as well. That is a trans-equatorial coronal hole. That'll show up in about 4 or 5 days. And we're going to move to sunspots here, but first let's do a cosmic ray report. So we haven't done one for a while. Here is your cosmic ray report. We'll start out with going as far south as we can get to Antarctica. So we see a little uptick there over the past 30 days at DOMB Antarctica, DOMC Antarctica. I'm sorry, that is DOMC Antarctica. There's DOMB Antarctica. And that is flat over the past 30 days. Going up north to Oulu, Finland, we see a small uptick over the past 30 days at Oulu, Finland. Let's head way down south to Mexico. So there's our Mexico City Cosmic Ray Observatory, and we see an uptick at Mexico City over the past 30 days as well, despite such a major uptick in solar activity over that period. Next, going to Greece, there's the Athens Neutron Monitor, also an uptick at Athens over the past 30 days. Again, despite all that solar activity that we've seen, an uptick in cosmic ray flux over most of our monitors. So now we're way back up north again to Apatity, where there has been an uptick over the past 30 days in neutron monitor flux. And last but not least, Barentsburg. Also display, let's see, Barentsburg is actually a downtick. So that's the outlier there. For the most part, a small uptick over the past 30 days over most cosmic ray monitors. Next, we'll get to sunspots. Here's your sunspot report. We're going to have a massive dip in sunspot number here along with the radio flux. So no surprise there, although there may be an active region rising down here. We'll let you know by the end of the video if that is a sunspot at the moment. So again, currently no sunspots in the southern hemisphere. All the sunspot groups are in the northern hemisphere. They are fairly small. Some of them are magnetically complex, and we've actually seen some reduction here. Some of those spots have actually evaporated since yesterday. So that's the past 24 hours. The SDO continuum. We'll let that play through one more time. So significant downtick there in sunspots over the past 24 hours. Next, we'll look at energetic particles and no spikes in the proton flux. So we'll get to solar flares, but first, let's talk about the channel. If you want to support the channel, consider becoming a member of the Smash Team at smashomash.com/Smash Team. We do send out email alerts, and we just launched our subscription services site back in October of 2021. So if you want to help support the content, become a silver or gold level Smash Team member. The best value is the gold annual paid up subscription. That includes complimentary merch, which is almost like getting 4 months of a gold membership for free. Smashomash.com/Smash Team, the official subscription services site of the Smash News Network, least busted name in news. We are also on Patreon. If you prefer to support us there, donate to us on Patreon. And keep in mind, if you become a gold member at the Smash Team, we will tell you the mechanism underlying the solar sunspot cycles and solar polar field reversal cycles. You'll be helping us write the paper. Next, if you're interested in merch, check the links below the video. You'll find the Redbubble shop there in order of best selling. Of course, it does contain words that we cannot say in a YouTube video because of the pathetic, putrid, and disgusting censorship on the platform. But there is the merch anyway, and congratulations on surviving a global scamdemic so far. Today's featured product is "Do not pole vault the caldera," so we say it regularly. It's one of our taglines on the channel. To quote Winston Churchill, if you're going through hell, keep going. There is a light at the end of the tunnel, folks, and our finest days lie ahead. Some people might think that civilization is ending. Some people might not think civilization is ending, and they might just tell you so they can get your cash and grift. We're not saying anything of the sort. Our finest days lie ahead. So if you're going on a volcanic vacation, don't pole vault the caldera. Leave that vault pole at home, but make sure you bring our shirt with you or whatever merch you pick up. And thanks to everybody who has. It's got the YouTube channel and the URL for smashomash.com. This public service message brought to you at massive personal risk and expense by Smash staff and I. Next, looking at solar flaring. And we've had one M-class flare since yesterday. Besides that, only C-class intensifications, and we are at a C-class background level anyway. Let's take a look at some imagery from SDO 94 angstroms. That's the past 24 hours. We'll also show 131 angstroms. Just to show a little bit of additional data here, here is 131 plus 171 angstroms. So that's great at showing magnetic field lines as the plasma in the solar corona. It does indeed align to magnetic fields. It's not magic, but it does align to magnetic fields. So don't get it confused, folks. Plasma is not the magnetic fields. Plasma aligns to the fields. And that's great imagery there to show you that field alignment. Two different species of ionized iron and their ultraviolet emissions are depicted there with 171 plus 131 angstroms. Continuing on to a star chart. So if you are up before dawn, you might see Mercury rising ahead of the sun. And we've got Castor and Pollux here, just about to set on the western horizon over Lehigh Valley, Pennsylvania. If you want to create your own sky chart, Scarchite. If you want to create your own Scarchite, head to skyandtelescope.org. Here's your solar system forecast. This is where heavenly bodies are currently. We'll advance this 1 week. There's where things will be in a week. We will have a gibbous waxing moon, only a couple days from full moon there. We're about 9 days off from a full moon, maybe 10 days. That's where things will be on February 3rd. And how time flies when you're massively overworked and underpaid. Next, looking at coronagraphs. And this is the coronal mass ejection report, and there have been a few. Are they earthly directed? Should you dig your bunker a few feet deeper today? We'll let you know here in just a moment. Is your bunker just the right depth? Is it too shallow, or are you in an ultra-deep military bunker? Are you too deep down? I mean, are you in a deep underground military bunker? Is it too deep to be safe? I mean, let us know in the comments. Let us know in the comments if you're viewing this video from a bunker. Anyway, there are 34 frames from today. Let's take a look at stereo A, which is located right here at Lagrange point 5, and Soho Lasco C3 located here at Lagrange point 1. So we paused this at 154 approximately because this is probably the most spectacular CME in the past 24 hours. And lots of solar plasma headed off there to the south, but not headed toward Earth. It's a little bit off to the west as well. So at least that CME, not earthly directed. So let's just let these play through here as there may be some other events to take a look at. Keep in mind these are not time synced, so pay attention to the time and date stamps. There's a little bit less data on stereo A. It's still 90 frames, so it goes back a little bit farther in time. So for a CME to be earthly directed, it would have to be off in this direction of my arrow from stereo A's perspective. We don't see anything of the sort. We don't believe there are any CMEs headed Earth's way at the moment. So here's the last 24 hours in composite. Great imagery there from SDO plus the Soho Lasco C2 and C3 in red and blue respectively. There's the zoom out. And let's zoom out one more level here. Great imagery there. Plenty of CMEs happening. They're just a light show. They are not directed toward Earth. So don't expect civilization to end, and certainly not as a result of that activity. Next, looking at filaments. And we've still got massive filaments and quite a lot of them. So you can see these prominences, those are filaments that hang off the limb. These dark absorption features, those are also filaments. Suspended by magnetic fields in the solar corona. That plasma is aligned to magnetic fields. And I would once again cite that stars and planets and plasma, space in general, is not magic. These things obey the laws of physics. And that's one of the many reasons why we say regularly that the universe is not electric. Look at the seriousness in my face. The universe is not electric. Many things are electric. The universe in general is not electric. So here's the latest frame, and we invite you to join us on Twitter. If you're able to see the tweets, we would be surprised, frankly, because of shadow bands continuing over there. And we'll say name that filament. Yeah, we're making a hashtag for it now. Name that filament. So drop us a line over on Twitter. If you don't have a Twitter account, create one. And make sure you follow us. We're all the way up to 373 followers, despite having 18.6 thousand tweets, daily content, our own web ring, and having been on the platform since March of 2019. Seems a little bit questionable, wouldn't you say? Here's the last 24 hours in ionized helium. Great at showing filaments, such as this one over here. That's the James Comer filament. And yeah, that's just great imagery there from SDO. Such a dope observatory the Solar Dynamics Observatory is. And here's the last couple of hours from GOES 16 SUVI with its awesome wide field of view. A little bit less resolution there, a little bit wider field of view. Great at showing coronal mass ejections as they happen. That's why we stream it regularly on Twitch at twitch.tv/smashomash. Continuing on to our bonus features segment. Charging hazards for satellites is the first thing, as this can affect your data. Yes, this might affect your weather satellites, for example, but at the moment, no charging hazards. So things are smooth for satellites. And we've seen a dip in the electron flux here, just as we forecasted yesterday. That's the past 3 days, as measured by the GOES 16 and GOES 18, using radiography from their geosynchronous orbits. Here is our forecast model. And while we didn't get as low as I expected, we were much lower than NOAA's forecast. So that is a successful forecast. That's called understanding the physics and the interaction between coronal hole high-speed streams and, well, Earth's F-flare. So anyway, that's what's going on at the moment. The green boxes are the forecast. The yellow diamonds are the observation. And here's the one-year chart to put that in context. We're just sort of in a moderate to low range there of relativistic electrons. Next, let's take a look at the portion of the atmosphere where those are measured. The F-flare, which is 300 kilometers of altitude. And we'll show the vibrational frequency and anomalygram of that shell. The F ionosphere layer, that's about 300 kilometers of altitude, and the vibrational frequency of that portion of the thermosphere. That's what's going on. We see continued migration of the South Atlantic anomaly. It's no longer in the South Atlantic. It's no longer over South America. It's not even in the South Pacific, really. It's just barely south of the equator. As that anomaly approaches the equatorial region, it is exactly where you would expect it to be if the current polar magnetic excursion is ending. Yeah, ending. It might be more obvious in the anomalygram. The South Atlantic anomaly is now way up here, just a few degrees south of the equator, which, by the way, at the equator is where you would expect the weak points in the magnetosphere to be. That would make sense. And lots of signs are pointing to the idea that Earth's magnetic excursion is ending. So for everybody who's grifting on this idea that Earth's magnetic poles are going to reverse, sorry about that, but you should just probably abandon bad theories. When all the facts refute your theory is probably wrong, and you should probably abandon it. Also, another fun fact, as I bring up the latest image here, you should all remember that if you are unable to describe your own theories in simple terms, it's probably because either one, you don't understand them yourself, or two, they're nonsense. So take your pick. If you can't put your own theories in simple terms, people aren't going to be able to understand them anyway. and they might be nonsense. Anyway, there's the latest image from the F-flare. That's 11:30 Universal Time ionogram, and there's 11:30 Universal Time anomalygram. Continuing on to look at the total electron content forecast, which has gotten a little bit more organized here, surprisingly, despite a coronal hole wind stream currently showing up. The total electron content shows your electron content between your GPS satellite and your handset. That's about 12,500 miles of altitude down to ground level. And while we do see some significant anomalies here, it's getting a little bit more organized. The electrons seem to be becoming a little bit more concentrated around the equator at noontime, which is what you would expect. So we see the electron anomalies waning here. Now we still do see these odd low electron contents over the Caribbean, southern South America. However, it is getting less anomalous. So we'll see less GPS errors than yesterday, and certainly less GPS errors than a week ago. Lower levels of anomaly. I guess it's not news. If it doesn't frighten you, maybe we ought to not cover it. Anyway, facts are facts. And here is the latest intensitygram and latest colorized magnetogram. So do we have any active regions? We do have a new sunspot down there. So check it out. Right there. New sunspot. That'll get a name today. Let's show the fields there. It's only alpha class at the moment, but there are a lot of fields around it. So there could be some larger spots behind it there. That's what you call a successful forecast. Sunspot rises in the southeast exactly as we forecasted. Is this active region a sunspot? Nope. Got some field complexity there. It could turn into one. And I wouldn't be surprised if it did, frankly. But at the moment, not. Anyway, here's your rock back. Major reduction here in radio flux and sunspot number. Next, we're going to do meteorology, but first take a moment to press like and subscribe. If you enjoy the content, press share, leave a comment, etc. Check out our playlists. There's lots of content besides daily space weather and meteorology. So check out those. Also check out the 12 Days of Smashmas from our music label, Golden Cat Productions. We're all over the internet, by the way. If you want to buy the music on Amazon Music, you can also stream it on Spotify. It's also on iTunes. We're all over the internet, Golden Cat Productions. Our record label, the official record label of the Smash News Network, least busted name and news. Thanks, YouTube viewers, for tolerating the pathetic and putrid censorship on the platform. If you're viewing on BitChute, you're missing most of our content, so make sure you become a subscriber over on YouTube, and help us out with clicks. If you're unable to do or unwilling to do anything else, visit our website at smashamash.com and check out our homepage and the other links there. Visit us on social media. Let us know in the comments what your favorite social media is. Perhaps pick up some Hemp Lucid products or improve your health with an association membership with the American Better Health Organization, otherwise known as SureMed. Let's get to the realm of meteorology here. So interestingly enough, we've got this low pressure. It's pretty weak in the Atlantic, but it's kicking up quite a bit of lightning. So I was looking for a better way to show this to you. That low right there, it's associated with significant thunderstorm activity there. So what we're actually looking is this is the mean sea level pressure, and it's not really that low. It's nothing like this low up here, where the pressure is all the way down at 973. I mean, it's much higher pressure than that, but there are quite significant thunderstorms. Anyway, let's take a look at the total precipitable water. There you can see quite a bit of moisture there, but not a super strong low, and it is generating quite a bit of lightning. Winds aren't super strong either. And let's take a look at the winds around the planet. So these are the surface winds for the eastern world. These are the jet streams of the east. Jet streams of the west depicted here. Let me rotate a little bit. There we go. Huge divergence in the jet stream there in the Atlantic Ocean continues. And a powerful high pressure here around the North Polar region there. That's a huge upper level high pressure. A low pressure rather. It's rotating counterclockwise there in the northern hemisphere. That is a strong low pressure. probably shifting the jet stream to the north, really. In any case, those are the surface winds of the western world. Here are the surface winds of the central world. And these are the jet streams. Backward jet stream here over the western Indian Ocean and central Africa. The jet stream blowing there east to west. Continuing on, we want to see what clouds and fog look like here over the Americas. And thanks for leaving a comment, Jackie2. So that's our 3.9 nanometer radiation satellite, giving you insight into what's going on Crescent Earth on the west side. Shout out to my viewers from the west side. And there you can see that strong system there. Not a strong low, but lots of lightning. We'll get to it. Next, our weather.gov map. If your location is lit, click your location. There is the key so you can see what that might mean. Weather.gov. It's looking like some stormy days there on the Great Lakes. Let's do some forecasts as there's some very cold air intruding from the polar regions here. So check it out. You've got very, very cold temperatures here making their way into Idaho, Wyoming, Montana, the Dakotas, Nebraska, all the way down into Texas, indeed. In the next 3 days, that's your GFS temperature anomaly forecast in degrees Celsius. We've got some extremely warm temperatures coming to the Middle East, to the mid-Atlantic states, and some really cold temperatures coming to the north-central U.S. Here's your pressure and precipitation forecast for the same period and the same model. It's a GFS 72-hour pressure and precipitation forecast. Some strong storms coming to the Gulf Coast here, so beware of that. Louisiana, Mississippi, Alabama, Georgia, and the Florida Panhandle. Expecting to see some severe weather there. Especially southern Georgia, actually. Next, we're going to show you your windy.com map. This is the 3-day forecast for new snow based on the Euro model. And we'll also show the GFS model. So that's the Euro model for the next 72 hours. There's the GFS model. You can see they're quite similar. It's usually a good sign indicating that the forecasts are accurate. When we see the models aligning that way, that is generally a sign of accuracy. 72-hour forecasts are fairly reliable. So here's our NASA GOES lightning mapper, and you can see all that lightning kicked up by that system there in the north-central Atlantic. Let's take a look at a real-time lightning map. Is it still striking? Well, let's consult lightningmaps.org and find out. Indeed, we still do have some active cells in there, it looks like. Maybe not. Let's zoom out, but the next time you hear thunder, check it out. lightningmaps.org. It's a good time. Convince the natives that you're Zeus or perhaps Thor by forecasting thunder. As there is some rolling in the eastern Mediterranean. See quite a bit of activity there, and there's some activity in the North Atlantic as well. And there's some activity in the equatorial Pacific. Continuing on, this is where we will close things out. Our U.S. Doppler radar map. We're showing the full 50 states of ALSA there, former nation, now Banana Republic. There is the lower 48 view, some snow around the Great Lakes and the northern Rockies. Here's shortwave radiation showing clouds and fog. It's still dark over most of the country. And there is your water vapor map. We got a string of dry massive air there, going all the way from San Francisco to Newfoundland, which is effectively a high pressure system. It's essentially creating a boundary here between this northern air, slowing it down a little bit there. It will run into that air like a wall. That is effectively a high-pressure system with respect to the more moist air around it. And here's your recap to close out our video for today. U.S. Doppler radar. Shortwave radiation showing clouds and fog. And water vapor Very definitive if your Doppler is not giving you the full story. Check the water vapor map. Be a baller on your next flight and know when you'll hit turbulence, because that dry mass of air is indeed more massive. It's like running into a wall. And flying into moist air is like flying up over a pit and getting sucked into it. So anyway, thanks for tuning into the Smash News Network, least busted name in news. We enjoy citing facts and debunking nonsense. So I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back. Facts stated in this video suppressed by big tech criminal organizations to improve your online experience. Opinions expressed in this video not necessarily the opinions of Smash News Network, least busted name in news.